Science 14, Unit C, Section 9.4, Medical Imaging and Diagnosis. Medical professionals, such as doctors and nurses, use various techniques and tools to diagnose injuries and illnesses. A blood pressure cuff is one of these, also known as a sphygmomanometer, if anybody asks, is used to check your blood pressure. A stethoscope is used to listen to the heart and lungs and to check heart rate and to look like a doctor. And an endoscope is a camera with a light on the end of a rigid or flexible tube that allows us to see inside the body. Endo meaning inside, and scope relating to looking. X-rays can be used to take pictures of bones or other dense structures. Fluoroscopy involves putting the patient between an X-ray source and a screen. Allows for real-time imaging of what's happening inside the body. And a CAT scan, computed axial tomography, or some other ways of saying it, also called a CT scan for a computerized tomography scan, something like that, but CAT sounds cooler, I think. It's a 3D X-ray of tissues or bones, so they take a bunch of X-rays from a bunch of different angles and put it together into a 3D image. And ultrasound imaging does similar sorts of things using high-frequency sound produced by a speaker or reflected off of... so it's high-frequency sound produced by a speaker rather than using X-rays, because sound is much nicer for us. And what happens again is that it's reflected off internal structures to produce real-time images safely. We don't do X-rays of developing tissues, particularly in the case of fetal development. Ultrasound is much safer. EKG, electrocardiogram, I don't know why it's a K, must be something German. That records the rate and pattern of heartbeats. And that's the thing you always see in the movies going beep, beep. Anyway. EEG, electroencephalogram, relating to the head, recording electrical patterns of the brain. And an MRI is magnetic resonance imaging, using magnets and radio waves to produce 3D images of internal structures. And of course, because it's using radio waves instead of X-rays, it's much safer, but somewhat more expensive, I think. I don't know, I'll have to check on that. Anyway, PET scans, positron emission tomography scans. They use emissions from positron collisions for 3D imaging. Basically, a positron collides with an electron and produces 2 gamma photons, and then we detect those gamma photons and we can tell where the collision occurred, and do that a million times and we can build an image of it. That is what we need to know about 9.4, medical imaging and diagnosis.